C2, Differentiation, past paper question, June 2009. So here we have a sort of wedge shape, and we're told that it's a closed box used by a shop for packing pieces of cake. The box is a right prism of height foot h. The cross section is a circle, and the sector has a radius r and angle of 1 radian. So we're told that the volume of the box is 300 centimeters cubed. So as to show that the surface area, s centimeters squared, is given by s equals r squared plus 1800 over r. So this is part A. So we know what the volume is. The volume is 300 centimeters cubed. So that means that the volume, which is given by a half r squared theta, and this time times h, because it's h high. So we know that theta is 1 radian, so that'll be equal to a half r squared h. So V equals r squared h over 2. And because we know that that is equal to 300 centimeters cubed, we can say that h is equal to 600 over r squared. So now we have an equation for h, we can find the surface area. So for the two sectors, we will have 2 times a half times r squared. So this is for the two sectors. So on the diagram, we have found the top and the base. And then we have two rectangular sides, so this one here and that one along the back. So they will be found by doing h times r, the height times the radius. So we're going to have plus h times r times 2 for the two rectangles. And now we need to find the length of the arc and times that by h as well. So the arc is r theta, so that's r times 1 times h, so that'll just give us rh again. And that's for the arc. So we'll put all these together. We have r squared plus 3rh. So the surface area, let's call that S, is equal to r squared plus 3rh. But of course, we have a value for h here, 600 over r squared. So instead of h, I'm going to write that now. So S equals r squared plus 3r times 600 over r squared. So that r cancels out with one of them r's. So S is equal to r squared plus 3 times 600 over r, which is of course equal to r squared plus 1800 over r. And if we have a look back to what we were trying to find, we have got it. So we have found this. So moving on to part B. Now we are asked to use calculus to find the value of r for which S is stationary. So if we have S equal to r squared plus 1800 r to the power of minus 1, we can find a stationary point by differentiating, so dy by dx, and finding where that is equal to 0. So that's where we will find a stationary point. So dy by dx, or in this case, it will be ds by dr. So that will give us 2r minus 1800 r to the minus 2. So that is the same as 2r minus 1800 over r squared, and of course we're looking for where that is equal to 0. So I'm going to take the 2r over to the other side, well, the 1800 over r squared to the other side, so that'll give me 2r equals 1800 over r squared. I'm going to multiply through by the r squared and divide by the 2, which will get me r cubed equals 900. So now to find r, I just find the cube root of 900, which gives me 9.65 centimetres. So that is where the stationary point is. So for C, we need to prove that the value of r gives a minimum value of s. So we'll start off by doing the second differential. So for C, we'll do d to s by dr squared. So of course, we're doing that on what we found for here. So we're doing the second differential of what we found here. So of course that first r will disappear to give us just 2. Then we'll have plus 3600 r to the minus 3. So that is equal to 2 plus 3600 over r cubed. And if we substitute in r equals 9.65, we end up with a value that is greater than 0. So that means that the surface area is a minimum at r equals 9.65 centimetres. And now for part D, we just have to find to the nearest centimetre the value of s. So now all we're doing is going back to what we have for s and substituting in r. So that'll be 9.65 squared plus 1800 over 9.65, and when you type that into your calculator, you get 279.65 centimetres squared. But of course, we want this to the nearest centimetre, so that means that we end up with the surface area S is equal to 280 centimetres squared to the nearest centimetre. So we have found all the parts to our question.